Voyager 1, NASA's farthest traveling rocket, continues its incredible journey through space, flawlessly transmitting significant data from the deepest regions of the universe for almost 50 years. This phenomenal space probe has revolutionized our understanding of space. However, in recent times, it has been sending back disturbing signals to Earth, leaving the entire space industry in shock. Are these troubling signals the result of a technical breakdown, or could they be linked to extraterrestrial activity? Join us as we uncover the reality behind these stunning transmissions. Since the dawn of recorded history, researchers have been captivated by the mysteries beyond our heavenly boundaries. This curiosity led to the historic launch of Voyager 1 and Voyager 2, along with other groundbreaking space missions. These momentous missions, long discussed before their execution, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5 of the same year, Voyager 1 followed. These twin probes, each weighing approximately 720 kilograms, comparable to a small vehicle, were launched into space during a rare alignment of the outer planets. Throughout their staggering odyssey, these courageous probes navigated different trajectories and speeds, leading to a crucial moment on December 15, 1977, when Voyager 1 surpassed its twin due to variations in their paths. Since then, Voyager 1 has been an invaluable asset, providing a wealth of data and unraveling space-related mysteries. Before we explore Voyager 1's startling new discovery that has shocked the entire space industry, let's revisit the extraordinary images it captured during its pivotal Jovian imaging mission in 1978. At that time, Voyager 1 was positioned approximately 265 million kilometers from Earth. From this vantage point, it transmitted an astonishing number of images back home. In January 1979, it embarked on an exceptional 100-hour endeavor, capturing a mesmerizing time-lapse sequence of Jupiter's rotation. This collection of 3,750 images showcased Jupiter's magnificent atmospheric movements in vivid detail. In the ensuing months, Voyager 1 ventured through the Jovian moon system, making a striking discovery: the presence of a faint ring around Jupiter and two previously unknown moons, expanding our understanding of Jupiter's fascinating domain. To ensure safe passage and prevent a potential collision with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 then continued its celestial journey around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tessis, Dione, and Rhea. With the conclusion of the Saturn mission, researchers decided to extend the Voyager mission beyond the planetary boundaries, propelling both Voyager 1 and Voyager 2 into interstellar space at an astonishing speed of 325 million kilometers per year. In January 1990, a new chapter began with the Voyager interstellar mission. During this stage, Voyager 1 captured some of the most iconic images in history, immortalizing the Sun and most of the planets. One individual who played a pivotal role in extending the missions beyond their initial objectives was the prominent astronomer Dr. Vasily Sands. As part of the Voyager mission's imaging team, Dr. Sands passionately advocated for capturing a final set of images as a farewell gift to humanity. Against all odds, his perseverance paid off. On February 14, 1990, when Voyager 1 was positioned 6 billion kilometers from the Sun, it embarked on a breathtaking photographic excursion known as the Family Portrait of the Solar System. These stunning images, totaling 60, were added to Voyager's already remarkable collection of 670 photos taken during its encounter with Neptune. Voyager 2 also achieved extraordinary milestones. During its flyby of Neptune, it recorded the fastest wind speeds ever documented within our solar system, exceeding 13,100 meters per second. As the probe ventured within 280 million kilometers of Neptune's blue methane atmosphere, it provided us with invaluable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest objects in our solar system, with surface temperatures plummeting to a frigid -391 degrees Fahrenheit. Triton's peculiar characteristics, such as nitrogen gas-spewing ice volcanoes ejecting icy particles 5 miles into its hazy atmosphere, further captured the imagination of scientists. These exceptional discoveries significantly expanded our understanding of the diversity and complexity of celestial objects in the farthest reaches of our planetary system. But don't go anywhere, Voyager 1 has recently made one of its most frightening discoveries. Before diving into this latest revelation, let's first examine what the probe has achieved over the past 45 years. The accomplishments of the Voyager twin missions have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe, shattering previous assumptions about these distant worlds. These moons, once thought to be dormant and heavily cratered like our own moon, were revealed to be geologically active. Voyager 2, in particular, achieved several groundbreaking feats during its journey. In 1986, it became the first spacecraft to fly by Uranus, and just 3 years later, it made history once again with a flyby of Neptune. To this day, it remains the only probe to have traveled such a path. As the Voyager spacecraft continue their journey, NASA has implemented several strategies to prolong their operational lifespan. Over the years, unnecessary systems and heaters have been shut down to conserve energy, ensuring that these resilient explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this groundbreaking project since its inception, the eventual conclusion of the Voyager missions will be both a moment of pride and a testament to human ingenuity. A tinge of melancholy accompanies their steadfast dedication and passionate efforts, which have far surpassed their initial expectations. The wealth of data returned by the Voyagers has provided valuable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary space probes. They were meticulously designed as stable platforms with a rotation rate over 15 times slower than the hour hand of a clock. This deliberate design minimized visual blurring, allowing the spacecraft to capture clear images and data while journeying through the vastness of space. Even before their encounters with the outer planets, their impressive imaging abilities began to astonish scientists and the public alike. The spacecraft started transmitting images of Jupiter before even reaching the gas giant. These early images, displaying swirling clouds and the iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected peculiar signals from Io, which were later confirmed by distinctive images revealing towering volcanic plumes and a surface scarred by intense volcanic eruptions. One of Io's most prominent volcanoes erupted with a force 10 times greater than Mount St. Helens, covering an area almost the size of France. While the spacecraft's cameras were eventually shut down to conserve power and memory before their journey into interstellar space, it is noteworthy that the photographs they captured did not include Mercury and Mars for various reasons. Besides Voyager 1 and Voyager 2, NASA has also operated other prominent interstellar probes, such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Voyager 1 continued its solitary journey for another 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes nearby to witness the event, NASA did not publicly announce this remarkable achievement until 2013. What procedures ensured the success of the Voyager missions? One method stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played an essential role in propelling Voyager 1 and Voyager 2 on their ambitious journey to explore the outer reaches of our solar system. To reach these distant destinations and collect valuable data, the spacecraft needed more than just their onboard propulsion systems. They needed an extra push, and gravity assists provided precisely that. Imagine the two fearless probes, Voyager 1 and Voyager 2, embarking on their grand tour of the solar system. Instead of relying solely on their thrusters, they engaged in a celestial dance with some of the solar system's heavyweights. These planets formed a cosmic choreography, using their immense gravitational pull to slingshot the spacecraft forward, conserving valuable fuel while gaining the speed necessary to reach various destinations. Delving into the fundamentals of gravity assist, also known as a gravitational slingshot, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it flies by. Imagine Voyager 1 approaching Jupiter, a massive gas giant with an immense gravitational pull. With meticulous precision, Voyager 1 swung by Jupiter at the perfect angle and speed. Jupiter's gravity pulled at the spacecraft, accelerating it to a higher velocity and providing it with a crucial boost. Performing a gravity assist maneuver requires exceptional accuracy. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot effect could have resulted in a disastrous deviation from its intended trajectory. The level of precision required for such maneuvers is daunting. However, the brilliant minds behind these missions successfully executed multiple gravity assists, propelling the Voyager spacecraft on an astonishing journey through the solar system. Voyager 2, for example, used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of vital importance in making the Grand Tour possible. The Voyager missions owe much of their success to these gravity assist techniques, which allowed Voyager 1 to reach interstellar space, with Voyager 2 quickly following suit, all thanks to the accuracy of these slingshot maneuvers. While the concept of gravity assist is simple, its execution is highly complex. Voyager 2's Grand Tour required an extraordinary level of precision. Missing any of these critical slingshots could have resulted in mission failure. However, the dedicated individuals behind these missions remained determined and steadfast in their pursuit of knowledge. While gravity assist was a crucial factor in the success of the Voyager missions, another vital component ensured their longevity and effectiveness: the Deep Space Network, DSN. Often referred to as the interstellar phone line, the DSN kept us connected to our brave Voyager probes as they ventured into the great unknown. Though less flashy than the spacecraft themselves, the DSN was equally indispensable. The Deep Space Network is a system of massive radio antennas strategically positioned around the world, with locations in California, Spain, and Australia. These enormous dishes, ranging in size from 26 to an incredible 70 meters in diameter, act as powerful amplifiers, facilitating communication with spacecraft traveling beyond our planet. The Voyager probes, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To make sense of the data they sent and to provide them with new instructions, a robust communication system was essential. That's where the DSN came into play. Imagine Voyager 1 on its way to the outer reaches of the solar system, transmitting a message back to Earth as a faint signal traveling at the speed of light. As it journeys through the infinite expanse of space, the signal weakens. When the signal from Voyager 1 finally reaches Earth, it is nothing more than a faint whisper. However, the colossal radio antennas of the Deep Space Network, DSN, are poised to capture that whisper. These antennas lock onto Voyager's weak signal, work on it, and transform it into data that scientists can analyze. But the DSN does more than just receive signals, it also sends commands. The Voyager missions are dynamic endeavors, requiring scientists and engineers to adjust trajectories, redirect the spacecraft, or tweak instruments. These commands are sent via the DSN, which transmits them into space, reaching Voyager and guiding it. It operates as a two-way conversation between Earth and the farthest human-made objects in the universe. One remarkable aspect of the DSN is its tireless operation. It works 24/7, continuously listening for those distant signals. Like an unblinking eye on the universe, it ensures that we stay connected to our space probes, even when they are billions of miles away. The Voyager mission stands as a testament to the power of collaboration and innovation. While the spacecraft embarked on their grand journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. Did Voyager 1 experience a breakdown, or were aliens involved? Throughout its remarkable 45-year journey in space, the Voyager 1 space probe has remained healthy, diligently performing its mission. However, in recent times, experts have noticed some abnormalities in its performance, sparking interest and curiosity. Voyager 1 is currently sending peculiar signals back to Earth, creating the impression that it is uncertain about its exact location and coordinates. What makes this discovery even more perplexing is that the initial data received from Voyager 1 was incomprehensible and unimaginable, leaving NASA scientists puzzled. Upon examination, scientists found that the culprit behind the distorted data was the Attitude Articulation and Control System, AOCS. This embedded equipment is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It keeps Voyager 1's antenna directed toward Earth, enabling it to send data back home. The malfunction occurred when the software abruptly switched to transmitting its telemetry data through a faulty embedded computer that had been dormant for years. NASA engineers were able to correct this anomaly by instructing the spacecraft to resume sending data through the correct computer. As a result, uncorrupted data from Voyager 1 is once again reaching NASA. However, the question that remains unanswered is why the spacecraft switched to the malfunctioning computer in the first place.